question on mains electricity here. So we are shown a fuse and we're asked what colour the insulation covering the live wire in our plug is. So if you remember, we have 3 wires, a blue, a brown and a yellow and green one, and the live wire is the brown one. So that's the wire that brings the current into the appliance. Draw the circuit symbol for a fuse. A fuse is a rectangle with a line running straight through it. The fuse wire melts when there's a charge of 2 coulombs flowing for 400 milliseconds. Calculate the current in the fuse wire. So here we need to go to our formula sheet and find the charge is equal to current times time formula. And we want to rearrange that to make current the subject. So current is charge divided by time. But we need to spot here that we are given a time of 400 milliseconds. And remember, 1 millisecond is 1,000th of a second. So we need to convert that first of all. So our charge is 2 coulombs, dividing it by our time of 400 milliseconds, converted into seconds, which gives us a value of 5 amps. So now we're told that the fuse is at melting point and the additional energy needed to melt the wire is 1.02 joules. We're given the specific latent heat of the wire and asked to calculate the mass. So we need the equation for latent heat from our formula sheet, which is E is equal to mL, where L is the latent heat. We need to rearrange that because we're being asked to find mass. So mass is energy divided by latent heat. But if we spot our value for latent heat is given in kilojoules per kilogram. So we need to convert that to joules per kilogram, remembering that 1 kilojoule is 1,000 joules. So our value for the latent heat is actually 60 kilojoules, which is 60,000 joules. Now we can plug that in. So we have our 1.02 divided by 60,000, and that gives us a value for the mass of 1.7 times 10 to the minus 5 kilograms. The last question says that the previous question assumes there is no energy transfer to the surroundings. How would the time taken for the wire to melt be affected if some actually was? So what we're saying is of some of the energy that was being supplied, some of that is going to get lost to the surroundings. So not all of the energy is going to go straight into melting that fuse wire. So if that's the case, then the time taken is going to increase because actually we're going to need more energy in total is going to need to be transferred.